We will discuss two kinds of functions. As the title suggests, one would be called power function, the other is exponential. And it's always better to begin with examples. So what is an example of a power function? So power function looks like this. Your independent variable is down below, and in the exponent you're going to have a number, say x square. Then how does this compare to an exponential function? So first of all, what is an exponential function? An exponential function is where the variable is sitting up high in the exponent position. So x square is a power function and it's a polynomial, whereas this is exponential. A lot of times, not a lot of times, but sometimes students confuse between, they think that x square is an exponential function just because it has an exponent. But let me tell you, if the exponent is a number, then it's not an exponential function. For exponential functions, the exponent is in, the variable is in the exponent position. Alright, so this is structurally how they are different. Now notice, if I were to build a table of values for different x, so let's see how f of x varies. So when x is, so let's write down some values of x here and f of x here. So when x is 1, x square is also 1. When x is 2, it's 4. 2 square is 4. 3 square is 9. They're getting bigger. And let's skip some and let's write down 10. 10 square is 100. And then maybe I want to skip some more and write down 20. And 20 square is 400. So when x is increasing, f of x is also increasing, and you may say that this is increasing more rapidly than that. Now, let's look at what happens in exponential functions. So let's write down again x on the left and g of x equals 2 to the x. So when x is 1, g of x is 2. So somewhat comparable. When x is 2, g of x is 4. In fact, this row they are the same. And when x is 3, g of x is only 8. So these numbers looks similar to these numbers, not much different. Now when x goes up to 10 though, 2 to the 10 is actually 1024. So that's, you can see that when x goes up to 10 here, f of x only went up to 100, but now it has gone up to 1000. And when x goes up to 20, this is going to be more than 1,000,000. And let's just say it that way, more than 1,000,000. Notice, here it's only 20, when x is 20, it's only 400. But here it has gone up to more than 1,000,000. They both started almost the same, but this has risen so much. And that's the characteristic of exponential functions. If the base is more than 1, this is going to grow rapidly. Now, let's also talk about their inverses. The inverse of square function is square root. So if x squares grow, then square root x also grows, but it does not grow as rapidly. Now what is the inverse? Inverse of exponential function would be called logarithm. So this will be log, and if the base of the exponent is 2, then the inverse of 2 to the x is log base 2 of x.